everybody. In this video, we're going to be talking about combinations. So take 3 deep breaths and let's make this math easy. Okay, so the first thing I want to say to start off our conversation about combinations is that permutations and combinations are really similar to each other with one key distinct difference. So in both permutations and combinations, you're going to be choosing a certain number of items from a group of objects. And your first choice will impact your second choice, which will impact your third choice, and so on. So that's true for both permutations and combinations. The thing that's different about these two is that when you're working with permutations, the order that you choose the things in matters. And with combinations, the order doesn't matter. So to see an example of what this would look like in a word problem, a permutation would be if you were asked how many ways can you choose a president, vice president, and secretary from a group of 4 people. A combination would be if you were asked how many ways can you choose a 3-person committee from a group of 4 people. So these are different because in the first case, if you chose person A to be the president, and then person B to be the vice president, and person C to be the secretary, that would be different than if you chose person C to be the president, person B to be the vice president, and person A to be the secretary. Those are considered to be 2 different things because you have a different person who's the president and the secretary. But if you were looking at a 3-person committee, these 2 things would be considered to be the same because it's just a 3-person committee and it doesn't matter which order you list their names in. So with permutations, the order does matter, and with combinations, the order does not matter. And that's really the only difference between these 2. And what we'll find is that the permutation formula is actually part of the formula for the combination formula. So let's look at how this would work in a choice tree. So let's say that we wanted to choose a 3-person committee from a group of 4 people. Well, the first person on our committee could be any one of the 4 people. So our choice tree would have 4 branches for the first one, and I drew it sideways to the direction that I normally draw it, just so it would fit on the PowerPoint slide. But basically, that's our first layer of our choice tree, and those are the number of options we have for the first person on our committee. Then the second layer is going to have 3 branches branching off of each of those, because we couldn't have whoever we chose as the first person also be the second person. So we only have the 3 remaining people to choose from for the second person on the committee. And then, so let's say that we chose person A for the first person on the committee, person C for the second person on the committee. In that case, we would have 2 choices left for who could be the third person. It could either be person B or person D. And let's say that we chose person D. So that particular branch represents the choice of choosing person A as our first committee member, then person C as our second one, and person D as our third committee member. So we know how to calculate the number of branches in this choice tree because that's just a permutation. However, it's not a combination because this same group of 3 people shows up multiple times in our choice tree, because this group or this committee of person A, C, and D also shows up in this branch of the choice tree, because this branch of the choice tree represents person A being chosen first, then person D, and then person C. And then that same group of 3 people also shows up here, where person C was chosen first, then person A, then person D. And then in this branch of the choice tree, we chose person A, person D, and C, and then D and A. And notice that, again, it's the same 3 people in the committee, but this committee has been listed 4 times already. And if we look at this branch of the choice tree, it looks like they were chosen again. And in this branch, they were also chosen again. So there's 6 times that this same group of 3 committee members shows up in this choice tree. And even if we had chosen a different committee member or a committee group, so like let's say we chose ABC, so I'll do this in a different color. If we had chosen that committee where we chose person A, then person B, then person C, this branch is a duplicate of that because we chose A, then C, then B. This branch is also a duplicate of it because you have, B chosen first, and then A, and then C. And then this one was also a duplicate because they chose B, and then C, and then A. And then this branch, they chose C, and then A, and then B. And there should be one more. Oh, this one right here. That would be C, then B, then A. And so regardless of which committee you're looking at, any committee is going to be listed 6 times in this choice tree. And so the way that we deal with this is similar to what we did in Unit 1 when we talked about Hamiltonian paths, because basically like the factorials are kind of similar to the falling exponents that we use for permutations. And when we were doing Hamiltonian paths, we had duplicates where the path going one direction was the same path as the one going the other direction. So we divided by 2 because it was duplicated twice. But in this case, we're going to divide by 6 because each committee is listed 6 times. So the way that we would calculate this is, first of all, we would figure out the number of permutations in this choice tree. So the way we would do that is we would say, well, we're making 3 choices. We have 4 people to choose from for the first choice, then 3 people to choose for the second person on the committee, because we don't want to choose the first person that we chose again. And then we would have 2 remaining people to choose for the last person on our committee. And then we're going to divide this by the number 6, because in this choice tree that had a total of, 4 times 3 times 2 is 24. So there's 24 branches in this choice tree. And out of those 24 branches, each committee of 3 people is duplicated 6 times. So to account for that duplication, we're going to divide 24 by 6. So there's 4 different 3-person committees that we could choose from 4 people. So we've already listed 2 of them. We have the ones that are shown in blue and the ones that are shown in black. And then you would also have the other ones like A, B, D, which would show up a bunch of times. In fact, 6 specific times. I think it would be these ones. Those would be the another one of the 3-person committees. And then the last committee would be BCD, which we can see duplicated 6 times here. So we have 4 unique 3-person committees that we can form from 4 people. And one thing to keep in mind with combinations is that this number is not always 6. So in this particular example, the number of times that the committee was duplicated was 6, but depending on the problem, that number may be different. So the way that you calculate the number 6 is you do the factorial of the size of the group you're choosing. So in this case, we were doing a 3-person committee. So the way you would get the number 6 is by doing 3 times 2 times 1. And that tells you the number of different ways that the same committee will show up in the choice tree. So the general formula for combinations, the top part is calculated just like a permutation, where you take the number of options you have and you do a falling factorial, a falling exponent for however many choices you're making. So in this case, we were choosing 3 people to be on the committee. And then you divide by the number of times that any committee will be duplicated in the choice tree. And the way you calculate that is with a factorial. So this is the formula version for how you would calculate a combination. So here's a general formula for the combination formula. So the number of ways that you can choose k objects from a group of n objects when the order does not make a difference is n to the k following divided by k factorial. So when you compare these two formulas, notice that the permutation formula is part of the combination formula. You just divide it by the number of duplicates. And the reason why you divide by that number of duplicates is because in the combination situation, the order doesn't matter, but in permutations, the order does matter. So like the example earlier where you had a president, vice president, and secretary, in that case, you would use a permutation because the order that the letters are listed in makes a difference. But if you're just choosing a committee and it doesn't matter if the letters are mixed up or in a different order, it's still the same committee regardless, then you would use a combination. So let's do one example where we're not going to draw a choice tree, just so we can kind of talk through how you would think through it. So in this problem, it says, how many ways could you choose 4 friends to go on a trip if you have a friend group of 10 people? Okay, so in this problem, we're making 4 choices. So we're going to write out 4 spaces that will multiply together. And our first choice has 10 options because I could choose any of the 10 people in my friend group. Then my second choice only has 9 options because I could choose any of the 9 remaining people that I didn't choose first because I already chose one of my friends to go on the trip. And then I have 8 options for the third person who could go on the trip and 7 options for the fourth person. Now, this calculation is going to give me a number that tells me all of the different ways that I could choose these 4 friends. However, in that choice tree, the same group of 4 friends is going to show up a bunch of different times listed in different orders. So like it might show up as ABCD, but then it will also show up as DCBA or BCAD. And there's going to be a bunch of different combinations of the same group of 4 friends. And since the order that I choose my friends in doesn't make a difference, like it's not like, oh, the first person gets first class and the second person, gets to go paragliding and the third person, I don't know, like there's nothing specific about the order that they're getting chosen in. And so all of those different combinations of the same 4 letters in the choice tree need to be counted as a single group of 4 friends rather than being counted as a bunch of different separate ones. So I'm going to divide by the number of duplicates in that choice tree and the number of ways that the same group of 4 friends will show up listed in different orders in the choice tree is 4 factorial. So 4 times 3 times 2 times 1. And when I multiply those together, 10 times 9 times 8 times 7 gives me 5,040. And 4 factorial gives me 24. And when I divide those, 5,040 divided by 24, that gives me 210 different ways that I could choose my 4 friends to go on the trip. And formula-wise, the way that you would write this would be 10 to the 4 following divided by 4 factorial. So that would be the formula form of that. And there is a way that you can type this into your calculator to have your calculator do all that work so you don't have to type out all the multiplication. So the button is in the same part of your calculator as the NPR button. It's just NCR. So NCR is for combinations and PR is for permutations. So in this case, the way you would type it in is you would type in a 10 and then go to the NCR button and then type a 4. So it should be 10 NCR 4. And then when you hit equals, you should get the same number 210 that we got by doing 5,040 divided by 42. So that's just a shortcut if you want to use it. And it can be helpful, especially when you have like a whole bunch of numbers that you're needing to multiply together. So that's how you would do that problem. Why don't you guys go ahead and try these 3 problems on your own? pause this video and then restart it to see how I would solve them. Okay, so the correct answer for the first problem is 1,365. Then the correct answer for the second problem is 56. And then the correct answer for the last problem is a really big number. It's 1,548,665 ways that you could assign these scholarship recipients. So if you got those same numbers, you're welcome to stop this video here. Or if you didn't get the same numbers as me on any of those, you can skip forward to the timestamps shown on the screen to see how I would solve those. Okay, so for this first one, it says, how many ways can you choose 4 unique ice cream flavors for an ice cream sundae when there are 15 options to choose from? Okay, so the way you want to think about this is you're making 4 choices. So we have 4 events that are happening, and the first event has 15 options to choose from because I have 15 ice cream flavors and I want to choose 4 of them. But the problem said that I needed to choose 4 unique ice cream flavors. So that means that my second ice cream flavor can't be the same one as my first one. And then my third ice cream flavor can't be the same as either of my first 2 choices. And my last one can't be the same as any of my first 3 choices. So I would have 12 options. So the number of ways that I could choose these ice cream flavors is 15 times 14 times 13 times 12. However, this is an ice cream sundae, and it really doesn't matter if I choose vanilla, chocolate, strawberry, and then mint, or if I choose them in a different order, because it's a sundae where they're all going to be accessible and I can eat them all at the same time. So since the order doesn't matter that I choose these ice cream flavors in, that means I need to divide out all of the duplicates of the same 4 ice cream flavors that show up multiple times in the choice tree. And the number of times that any group of 4 ice cream flavors will show up is 4 factorial. So I'm going to divide by 4 times 3 times 2 times 1. And formula-wise, what this would look like is it's 15 to the 4 falling, and then that's divided by 4 factorial. And you can either type in those 2 numbers or those 2 calculations, so figure out what 15 times 14 times 13 times 12 is, and then divide by whatever 4 times 3 times 2 times 1 is. You can do it that way, or you can use the NCR button on your calculator and type out 15 NCR 4. And when you do that, you find that there are 1,365 different ice cream sundaes that you could create with these 15 flavors of ice cream. So that's how you would do the first problem. And then for the second one, it says, how many ways can you draw a triangle inside of an octagon where the triangle and octagon share vertices? So this one might seem a little bit weird at first because it's like, wait, there's like no numbers, and now we're talking about shapes. Like, what does shapes have to do with probability and combinations? But if you think through what this is asking, you have an octagon, which I'll draw a picture to kind of help us think about it. And this octagon has 8 different vertices, meaning like the corners of the octagon. And we want to draw a triangle that shares vertices with the octagon, which means that we're going to choose 3 of the vertices and then use those vertices to form a triangle. So like if I chose these 3 vertices, it would form this triangle. But if I chose maybe like these 3 vertices, it would form a different triangle. So those are the triangles that we're trying to find. And the way we would think about this is we are choosing 3 different vertices. So we have 3 events happening. The first vertex can be any of the 8 available vertices. The second vertex has to be any of the 7 that we didn't already choose. And then the third vertex can be any of the 6 that we chose or haven't chosen yet. So we would multiply those together. And then we ask ourselves, does the order matter in this situation? So like if I chose this vertex and then this one and then this one, would that be a different triangle than if I had chosen this one first and then this one and then this one? And obviously it wouldn't, because both of those are going to create the same triangle that I've drawn there. And so the order doesn't matter. So that means that we would divide the duplicates of 3 vertices that are listed multiple times in the choice tree. And the number of times that they will show up in the choice tree is 3 times 2 times 1, or 3 factorial. So mathematically, the way that this would look in a formula is you would have 8 to the 3 falling divided by 3 factorial. And you can either calculate it by doing 8 times 7 times 6 and then dividing that by 3 times 2 times 1, or you can use the NCR button and do 8 NCR 3. In either case, you'll end up with the answer 56. So that's how you would do that problem. And then for this last problem, it says, how many ways can a scholarship committee select 6 scholarship recipients from 102 applicants? So in this problem, we're making 6 choices. And the first choice can be any of the 102 applicants, because the first recipient could be anyone that applied to the scholarship. The second recipient of the scholarship could be any of the 101 people who haven't already got the scholarship. The third recipient could be any of the 100 people who haven't got the scholarship after the first 2 have been chosen. And basically, you would continue this pattern down for a total of 6 numbers that are being multiplied, because you have 6 recipients that are being chosen. And then you divide this by 6 factorial, so 6 times 5 times 4 times 3 times 2 times 1. And the reason you do that is because the same group of 6 recipients is going to show up 6 factorial times in this choice tree. Now, obviously, you would never want to draw this choice tree because that's huge. Like, you have 102 branches, which are each branching out into 101, which branch out into 100, and so on. So that choice tree is really big, but we know how many branches will be in there, and we also know the number of the number of times that any group of 6 recipients will show up, and that's the 6 factorial. So formula-wise, what that would look like is 102 to the 6th falling divided by 6 factorial. And when you type that into your calculator, 102 NCR 6, whoa, that is a really big number. It's 1, 3, 4, 6, 5, 4, 8, 6, 6, 5. So 1.3 billion, over 1.3 billion ways to assign the scholarship recipients. So that's a very big number. But that's how you would solve that particular problem. So if you have any questions on this assignment, let me know.